So continuing on, we now need to write our reader class, our reader or consumer class. So let's go ahead and do that. So it's going to be class reader implements runnable, and we need a private message object. We need a constructor. Obviously, we're receiving the message object and we're saving it into our field. And then we need to create our run method. We're going to be doing something very similar to what we did in the write object, or the writer object and the run method up above, but instead we're going to be just reading the message and just printing it out. And then we're still going to delay for a random period of time. So we're going to do random equals new random to create our instance that we need of the random object for string latest message equals message.read. It's going to be our for loop. And we're going to wait for the message to say that it's finished to be received. So last message dot equals, and it's going to be finished. And this finished here has to be identical to the finish that we've defined there. So make sure you get the case sensitivity identical to avoid any weird errors. And then latest message is equal to message.read. So that's our for loop. And we're going to print out the latest message. Then we're going to pause for that period of time that I mentioned. Thread.sleep random.nextInt 2000. So up to 2 seconds we're going to sleep for. 2 parentheses to close that off. And we need to catch the exception, which is going to be the same exception as per the writer class, which will be the interrupted exception. And for now we won't do any coding in there. And we're not returning anything, so that is the end of the method. So as you can see, we're looping through the messages received. We're looking for the last message, which is finished, and we're processing each message, printing it out to the console, then waiting randomly up to 2 seconds, depending on what the random instance returns. So it'll be up to 2 seconds, and then exiting once we've printed out all the messages. So now we need to add the code to create and run these threads. So we're going to do this from our main method at the top. And incidentally, you might find that when you type this in, that IntelliJ will add imports for java.io.reader and java.io.writer because of these classes that we've created. So if they have been added up here in the import section, make sure you do remove those imports, otherwise you'll get compiler errors. Okay, so I'm going to now create that code. So it's going to be message is equal to new message, and then we're going to put new thread, new writer message dot start, like so. To start it, we're going to do the same for the reader class as well. New reader message.start. So let's run this now and just see what happens. Remembering that we've got delays built into this. So you can see that does seem to be a problem. And this does depend on the timing, but it is very likely when you run it, you'll get a situation like this on my computer where you won't see all the messages and the application appears to have hung. So we need to terminate it now because clearly 2 seconds has elapsed and we've only got that very first message. So I'm going to click on the stop button to stop the process. The process is now finished, as you can see, and I'll close down the run window. So looking at this, well, look, we've synchronized obviously the read method and also the write method in our message class. So what's actually going on? Well, if you think about it, hopefully it'll become pretty obvious as to what the problem is. And in fact, you might have spotted the error while I was writing the code. And the problem is that once one of the threads starts looping, the other one can't change the value of empty because the thread is blocked. Remember that only one synchronized method can run at a time. So the thread that's looping is holding the lock for the message object, and the other one is blocked, waiting for the other thread to release the lock. Now this is what's known or what's called a deadlock. And we're going to look at this situation in more detail in a later part of this section of the course. So we absolutely did need to synchronize both methods. So how do we actually get around this problem? Well, this is where the wait, the notify and notifyAll methods come into play. So when a thread calls the wait method, it will suspend execution and release whatever locks it's holding until another thread issues a notification that something important has happened. So you can probably guess that the other thread issues the notification by calling the notify or notifyAll methods. So we're going to call the wait method inside the message class's read and write methods. Now we'll also have each thread call notifyAll after it's changed the value of the empty variable. So let's go ahead and do that. So we'll go back to our loop here in message, and you can see while empty. So what we want to do here is in this first loop, this while empty for our read method in our message class, we need to introduce a try. Then we're going to call the wait method, as I mentioned, and we're needing the try block because we're calling thread code, and it catches, or we need to catch the interrupted exception. So that's for the read, and also for the write, we need to do exactly the same thing. So try, then within there we're going to call wait. We're going to catch the exception, like so. But there is one other thing we need to do, and that is call the notify method, or notifyAll in this case, after we've exited the while loop. So down here for the read method, notifyAll, I'm going to call that. And after we've set the field to our message in the write method, we're going to call notifyAll. So that should be it now. But before we test it, let's just go through and discuss a few things about this code. First of all, we're still looping. Now you might be wondering, well, why do we have to loop? Why not use an if statement, and if that fails, call wait? Well, the answer is that we always want to call wait within a for loop that's testing for whatever condition we're waiting on. Because when a thread is notified to wake up, there's no guarantee that it's being woken up because the condition it's waiting on has changed. So it's possible the operating system has woken it up for another reason, or it could have woken up because wait threw an interrupted exception. So we always want to call wait within a loop so that when it returns, because there's been a notification of some sort, we'll go back to the beginning of the loop, we check whatever condition we were interested in, and then we call wait again if the condition hasn't changed. So in other words, never assume that a thread is being woken up because the condition that it's waiting on has changed. Now the next thing here is you probably noticed I called notifyAll. So why are we calling notifyAll rather than notify? Well, because we can't notify a specific thread, and that's because the notify thread doesn't accept any parameters, it's conventional to use notifyAll unless we're dealing with a situation when there are, a significant number of threads that all perform a similar task waiting for a lock. So in that case, we don't want to wake up every thread because when there's a lot of them, that could result in a huge performance hit. So we'd call notify so that only one thread is woken up. Since all the threads are waiting to do a similar task, whichever thread is woken up should be able to proceed. So now that we've implemented or made changes to our code to use wait and notifyAll, let's run our application and see what happens. And this was the error that I was talking about earlier. Sometimes IntelliJ will add this extra import for some reason, so you just need to delete that to avoid the compilation errors. And it's got to do with the fact that we're using the class names writer and reader. So let's just run that again. And there you go. You can see that we've got our 4 messages printed and the code's working fine. You also saw that there was around about a 2-second delay, or up to a 2-second delay between each message. So each thread now waits and releases its lock on the message object when the loop condition passes. And that gives the other thread the opportunity to run. So it can now process a message and change the value of the empty variable. When it calls the notifyAll method, the thread that's waiting can now proceed. So the two threads go back and forth like this until all the messages have been printed. So before we move on to the next video, let's briefly touch on two more points. Firstly, when synchronizing code, always keep in mind that threads can be suspended while executing a single line of code. So a single line of code may well call a method that contains hundreds of lines of code, or a single line of code can contain many operations, and a thread can be suspended before or after each operation. So in the countdown example, you saw that the parameter we passed to the println method contains 2 method calls and 3 concatenation operations. As we saw, a thread can be suspended before or after performing any of these operations, and also while executing the println method itself. So having said that, there's a few atomic operations in Java that happen all at once. A thread can't be suspended in the middle of doing them. And here are the atomic operations in Java. Reading and writing reference variables. For example, the statement myObject1 equals myObject2 would be atomic. So a thread can't be suspended in the middle of executing that statement. Also, a thread can't be suspended if reading and writing primitive variables except those of type long and double. So the JVM may require 2 operations to read and write longs and doubles, and a thread can be suspended between each operation. For example, a thread can't be suspended in the middle of executing myInt equals 10, but it can be suspended in the middle of executing mydouble equals 1.234 for argument's sake. And the third scenario is reading and writing all variables declared volatile, but we'll be looking at volatile variables in a future video in this section. Now the second point I want to make is in relation to the collection classes. Some collections aren't thread safe. In other words, they're not synchronized. For example, ArrayList is not thread safe. When we read the documentation, which I'll put up on the screen in a second, we'll see that it states that the implementation's not synchronized. What that means is if we're using an array list in our application and multiple threads can access that at the same time, then we have to be responsible for synchronizing the code that uses the array list. Alternatively, after creating the array list, we can call collections.synchronizeList, the method, and pass it to the array list. So we still have to synchronize iterating over the list though. So for more information, you can check the documentation at this link, which will also be in the resources section. You can find out more about that very interesting read here talking about synchronization in the collections classes in Oracle's documentation. And out of interest, on the other hand, the vector class is synchronized. So if we use the vector class in our application, we wouldn't have to worry about multiple threads accessing the vector object at the same time. So in other words, the Java developers have synchronized the vector code so that it's thread safe. So that's all for synchronization. I hope you got a lot out of that. In the next lecture, we're going to take a look at classes in the java.util.concurrent package. See you in the next video.